Hi, this is Frank the Tutor. When you need to take the derivative of a complicated looking function like the one we have here, f of x equals x squared plus 1 all to the 5th power, it is a good idea to ask yourself, what if that thing in parentheses were just an x? Would I know what to do then? In this case, if that box in parentheses became x, we would be looking at f of x equals just x to the 5th. And we would know how to take the derivative of that. By the power rule, the derivative of x to the 5th is 5x to the 4th. So if you have this thought bubble and you realize you would know what to do if only the thing in the parentheses was x, then you probably are going to want to use the chain rule. I usually break the chain rule down into 4 steps. Step 1 we've done already, which is to box the thing. That thing in parentheses that we wished was x. Number 2, I want you to start imagining the box without the x squared plus 1 and just call it box, like f of x equals box to the 5th, and then casually take a derivative of box to the 5th. So if f of x equals box to the 5th, then casually speaking, the derivative of box to the 5th, that should be 5 box to the 4th. And so we write it, 5 box to the 4th. This next step is the most important. It's the one that people forget. It's what makes the chain rule unique, is that since we don't just have x in the parentheses, we do have something more complicated like x squared plus 1, we are obligated to continue by writing times d dx of the box. d dx here meaning the derivative with respect to x. And so we'll do that here. Times d dx of box. Step 4 is to fill in the boxes and proceed with the problem. So this box here had x squared plus 1 inside, so we'll put that in both places. If you've done it right, there should be 2 boxes on the line after there was 1 box. And so then f prime of x equals, we'll still say 5 times x squared plus 1 to the 4th, times, then the derivative of x squared plus 1 is 2x, so we say times 2x. An answer key might rewrite this, take the 5 times the 2x, and say 10x times x squared plus 1 to the 4th. Let's do another one. Okay, next, f of x equals the cosine of 4x. There's not a rule for the cosine of 4x, but there is a rule for the cosine of x. We ask ourselves, what if that thing in parentheses was just x? Would we know what to do? And we would. It would be the cosine of x. And the derivative of cosine x is negative sine x. So we do step 2, we're imagining the box without stuff inside. We should call this f of x equals cos box, and casually ask ourselves, what's the derivative of cos box? And we will say negative sine box. Then the crucial step 3, which is to say times d dx of the box. And now step 4, we'll fill in the boxes with what they used to have in them, 4x, and we proceed with the problem. We get negative sine 4x times, the derivative of 4x is just 4, in an answer key they'd probably sneak the 4 up front and get negative 4 sine of 4x. Let's do another one. Let's bring in e. F of x equals e to the negative x squared. We don't see parentheses, but whenever you have an exponent, there are implied parentheses around it. So this looks complicated, but we should be asking ourselves, what if that thing in parentheses were just an x? Would we know what to do then? it would look like f of x equals e to the x. And we do have a rule for the derivative of e to the x. The derivative of e to the x is e to the x. So we go to step 2 and we call it e to the box, forget about the negative x squared, and casually, what is the derivative of e to the box? We would say e to the box. But then because it's not just e to the x, it is e to the something else, the chain rule requires that we say times d dx of box. And that's step 3. Step 4, we fill in negative x squared in the boxes and proceed. E to the negative x squared times d dx of negative x squared, the derivative is negative 2x. An answer key would probably move the negative 2x up front, and we would get this. This one's pretty interesting. Let's do f of x equals sine squared x. What I usually tell my students is when you're doing derivatives, to remember that sine squared x is an abbreviation. It's an abbreviation for the sine of x in parentheses, all squared, and then it becomes a little more clear what to do. Here again we have this situation where if that thing in parentheses were just an x, I would know what to do. It would be f of x equals x squared, and we know the derivative of x squared is 2x. So step 2, we will look at this as if it was box squared, and casually speaking, what's the derivative of box squared? And we would say 2 box. But then because there was something in the box besides x, we have to say times d dx of box. And then we're ready to fill in the boxes with sine x. And proceed. 2 sine x, and now we worry about d dx of sine x. The derivative of sine x is cosine x, and we would get our answer 2 sine x cos x. Okay, I have one more for you. F of x equals the sine of e to the x. The thing in parentheses that we wish was an x is now e to the x. If that were just x, we would be looking at f of x equals sine x. So this is a good time for the chain rule. We should now call this sine box. And what is the derivative of sine box? It would be cos box. And then, because this is the chain rule, we must say times d dx of box. Now what was in those boxes we can fill in with e to the x. We would get the cosine of e to the x and then times d dx of e to the x, but the derivative of e to the x just is e to the x. In an answer key, I imagine they might write it like this, e to the x cos e to the x. That's enough examples for this video. Next we're going to look at how this way of writing out the chain rule can be really helpful for more difficult problems, especially when you mix in the product rule or the quotient rule, or even doing the chain rule multiple times in one problem. I hope this helped. Have fun.